All right, so this is back to the basic theory of matte creation, combining alphas and keying. So we're going to talk a little bit about keying and how do we apply it. I'm sure some of you guys already know what keying is and everything like that, especially if you've taken some of the other classes. But I just want to make sure the fundamentals are covered to make everyone on the same page so that nobody gets lost along the way. And this will be a brief overview of those things just to make sure that we all remember what those things are. So why are we using blue screens and green screens? If we remember, one of the main reasons is subject matter. So generally skin tones are more in the orange kind of yellowish tones, maybe a little bit desaturated, but generally over here on the color wheel, whereas a green screen and a blue screen are over here. So for filming human beings on a green screen, that's why we're using the color green. That's one reason. The other reason is, subject matter, generally not this bright green anyways. So, that's going to make it easier to pull a key. So we can see here a blue coat on a green screen. So that would be the very basic reason why we use a blue and a green screen. But on a little bit of a deeper level, there's also reasons why we choose blue over green. But if we just talk about this visible light as it pertains to human eye, so this is something I showed in Nuke 101, and we see that as the visible spectrum goes across, sort of in the center here is where the human eye is more sensitive to light, and that happens to be where the green and the yellows are. So actually here on the visible spectrum is where the brightest point is. So the green is going to become the brightest thing and easiest for a eye to see. But also cameras work the same way. So cameras are built to mimic the human eye. So essentially the number of samples here, if you imagine this is a camera sensor, this is called a Bayer pattern. So it's more sensitive to green light. So you see that there's blue and red squares, but there's like double the amount of green ones. So what they're using is, we have 3 color channels, red, green, and blue. And essentially what we're doing is we're using the green channel mostly for the luminance or the brightness of a picture. Because it's the most sensitive and just like our eye. So we're going to get more, not color, but light information by using that wavelength. So there's a bit more information on that if you want in the extra learning links about Bayer pattern and why we're using this. So there's more you can go much more technical and scientific than that, but as it pertains to our job as a compositor, that's really all you need to know. Is just that that's why we're doing that. So why would you choose a blue screen then? If the green is brighter and it cuts things out better, generally we go with green. Most of the time you're using a green screen, but you can imagine that maybe if there's a brighter background, you might have some more problems. So, for example, we're going to talk about spill, which is green light. When it's getting too much light on it, it's reflecting back onto the subject. So if this is our subject over here and we have a green screen and we're lighting it, we might get a little bit of like light reflecting back up onto that person, which is going to give the person a green cast around the edges. And because green is brighter, that light is going to be, have more energy and be more visible to us and the sensor. So we're going to get more green spill. But so if this was a daytime background that we wanted to replace, like we have a green screen, we want to put it in something bright, green screen would be fine. But sometimes they'll use blue screens when you want to replace a background with something dark. So if you're doing a nighttime shoot, you want to put the characters in some dark woods or something like that. A blue screen might be a better option for that. And that's how they're going to kind of approach it. So that's how you can think of it generally. But it's not to say that you can't use a green screen for a nighttime background or something like that. In fact, at the end of this class, we do use a green screen shot for a nighttime shot. And you can see that we'll actually see how we can fix some of the problems that come with using the green screen. And no matter blue screen or green screen, you're always going to have edge problems. It's more or less just if you use a blue screen on a nighttime thing, it might be a little bit faster to do in the compositing aspect. But ultimately, either one, you can still achieve the result you want. So it's just a matter of choice there. So on a very basic level, once again, keying is just, we're just trying to create an alpha. We're trying to create a cutout using a color so that we can do it faster, so we don't have to rotoscope all of this thing manually. So rotoscoping is trying to do the same thing. It's trying to create an alpha. We're drawing a shape around something that can't be keyed because it's not on a background that, it's not a solid color that we can just extract the image that we want off of it. So we're manually cutting it out with a rotoscope. And so these two processes are trying to achieve the same result, just using a different approach. One's doing kind of a mathematical procedural key, and one's doing a manual cutout. And of course, we can combine these two when we don't have, or when we have a more complex shot. And so we're going to talk about that a lot in this class. Once we move into the advanced projects, like for this shot is our kind of final project example. It's only half covered by green screen. So, we're going to have to combine many techniques to pull this off. There's some luminance keys that we could pull. So that's a key that just goes off the brightness. We will have to use some rotoscoping where there's areas that we just can't key at all. Like there's some black seams here and some different areas that we're going to have to worry about. So those are just the very basic problems associated with the shot. So there's going to be quite a lot to do. But it does involve keying and rotoscoping together. And so we'll look at that later.